Thank you, Sam. Am I audible?
Yep, you are.
Yep, thank you. Thank you. It's a great opportunity. Thank you, first of all, for inviting me. And thank you very much. It's 4 a.m. in the morning and I'm still being awake over here. That's pretty exciting. so,
Thank you. That's awesome.
so, yep. So let's begin. Browser exploitation for fun and profit. A bit about myself. My name is Dhiraj Mishra. I'm a bug hunter and I'm working with Ernst & Young. And if we didn't get a time for any Q&A, you can tweet me out on my handler. It's down below over there. So today's agenda is all about, like, we'll be talking about different types of browsers. We have browsers versus WebView or WebKit. Then we have something called as how a normal browsers works, basically. What are the components and what are the key components are there in the browsers? Apart from that, we have something called as BEEF, that's browser exploitation framework. But browsers comes with their own standard attacks, something called as CSP, SOP, and UXSS. Now, CSP is something called as content security policy. We'll be having a look on this on the further slides. Then there's something called as SOP, same origin policy. That's one of the core component, I believe, for the browsers. Then we have UXSS. We love XSS, cross-site scripting, and application security. In the similar fashion, we have UXSS, that's known as universal cross-site scripting for browsers. Apart from that, we'll be having a quick slides run through what are the key points for bug bounties in browsers. So yep, why browsers? Like, the very first question hits to everyone's mind, like, why browsers, why we are targeting them? So what basically I think is, like, nowadays browsers are the intermediate between you, your system, or your cell phones, which connect somewhere to the internet. So whatever you're trying to browse it right now, that's the help of browsers. And what I think personally, like, if the browsers gets vulnerable, by using various attack scenario, any person may have some or may not have access to your system without your concern. So that's why browsers are into the pictures, and they are the one level up for bug hunting or bug bounty programs as well. Apart from that, browsers have history. So bug bounty was started by Netscape Navigator in 1995. So yeah, this is one of the secondary reasons why bounties are over here for browsers. Okay, so let's have a quick run on this diagram. So we have something called as user interface, browser engine, rendering engine, networking, JavaScript interpreter, UI backhand, and data persistent. So let's have a look. So whatever you see in user interface, like your back button, your forward button, your omni bar, your advanced panel, where we configure our burp suite, everything that comes under UI panel. That's something called as user interface. Now, second thing is browser engine. Browser engine is something which facilitates between the rendering engine and the user interface. The third one is called as rendering engine. Now, rendering engine is something do a lot of stuff, basically. So rendering engine gathers all the information, collects the JavaScript, CSS, and HTML, and try to put it on the browser for you whenever you try to visit any website. So that comes under rendering engine block. Apart from that, there are three key components for rendering engine. That's something called as networking, JavaScript interpreter, and UI backhand. So networking, like whenever we try to visit a website, we use different protocols, HTTP, HTTPS, or we try to visit FTP or etc. So that all things comes under networking part. Apart from that, networking plays a very important role for resolving your DNS as well. Then the second key component is known as JavaScript interpreter. Like if we talk about a normal developers or attackers, when we try to write some sort of code or craft something, we try to miss out some closing the script tags or div tag or h1 or etc. To handle all that exceptions, this JavaScript interpreter blocks comes into the picture. So exception handling is basically done by the small block, which is known as JavaScript interpreter. Apart from that, we have something called UI backhand. Now, if you tell a browser, like, I want to see a triangle, I want to see a circle, this all thing is being done in the backhand by this block, which is known as UI backhand. Once done, it try to push up to the user interface so that we can actually see how it normally looks like. Now, there's something called as data persistence or a persistent layer. It's upon your right-hand side. So how basically, when we visit any application and when we try to log in, like when we do login, and once login, we get a small pop-up by saying that remember me. So once you try to click on that remember me, it stores some sort of passwords, session ID, everything, and it goes into this layer, which is known as data persistence. So that's how a normal walkthrough of a browser works. What this all are the small components and the key components of each and every browsers. So start from your Mozilla, Chrome, or any normal browsers, they will have all these interfaces, browser engine, rendering engine, and etc. Okay, moving further, there are some terminologies in browsers, some standard attacks as well. That's something called as info leak, if we talk about. Now, info leak is something which leaks your process or the kernel data from the memory through the browser. That's something called as info leak. We'll be not talking much about that over here, but I got a very good best slide from the Black Hat talk, which talks about this info leak. If you want to learn more about this, you can check out over there. Apart from that, we have denial of service attack. Now, majorly in bounties, specifically for browsers, they don't accept denial of service attack. I have seen on many of the browsers, like they keep it as a informative, or they'll say like it is not in our scope, or etc. If I give a very normal scenario over here, let's try to open a 50 to 60 MB of file. Just right click on it and try to open with browser. When you try to open with browser, your browser will work very normally for a particular time. After that, your browser says not responding. That's because rendering engine is not too capable of to render all those data. That's a huge amount of data. It cannot render properly, and it is not capable of showing you to the actual user interface. So that's our denial of service attack, and it's one of the very easiest way to DOS any browsers. Like DOSing a browser is not a difficult task over here. Apart from that, we have something called as code execution, that's RCE. This is something very interesting, and I would like to have a detailed discussion in the further slides. RCE is something called as when we try to execute any system-based file from from the system32, we are able to call cal.exe or cmd.exe or PowerShell.exe through the browser. That's something called as remote code executions in the browsers. Apart from that, we have fuzzing. Now, basically, browser has two core components. There's something called as DOM, that's known as Document Object Model, and second one is core. So we can perform fuzzing. We can do crashing of a browsers to various DLLs, and we can see which DLL got crashed and which not. We can use a GDB for this. We can use immunity debugger and etc. for doing fuzzing attacks over here. Now, fuzzings do comes under bounty programs. RCE comes under bounty programs, and even info leak as well. Denial of service will be exception for few of the browsers. So there are multiple browsers around the globe. Few accept denial of service attack, few are not. That's really not under the scope of their browser-based bug bounties. Apart from that, that's the very important thing, same origin policy. Then we have CSP, we'll be talking this on the first slide. We have XHR, that's something called as XML HTTP request. So whatever request you deals from the server or from API to API call, everything is been done by XHR. XHR is also one of the component or terminologies for browsers. Apart from that, we have spoofing based attack. Now, spoofing is again one of the simplest way to spoof the browser. Like we can spoof address bar, we can spoof content spoofing, we can spoof navigation, and etc. So spoofing plays also a very important role in what you can say browser based bug bounties. So if we talk about origin over here, just to give you a small idea, because further two slides will be about same origin policy. Now, origin is something, the combination of scheme, hostname, and port. Now, scheme is something your protocol, whatever you're using. Hostname is the combination of your host plus your TLD. That's something called as hostname. Then we have port. Together they call themselves as an origin. So just give you a small idea what origin is all about. So now, if we talk about same origin policy, like let's suppose a scenario where we have facebook.com open in one single tab, and there's second tab which is known as attacker.com, right? So you trust your browser that facebook.com tab will not share any single data to attacker.com. That's something called as maintaining the SOP between the browsers, right? So SOP was officially implemented by Netscape in 1996. So you trust your browsers that one tab will never share his personal data or whatever we are trying to browse to another tab. That's something called as same origin policy. So if you have to see a quick demo on it, let's have a look. We'll perform a SOP demo. We'll create a script. We'll craft a small JavaScript for this, where x equals XML HTTP request. X.open. Let's try to open any website in get method. HTTPS backrub.com. Let's make it true. x dot send and take the response back, document dot write x dot response text. Okay. And if everything goes well, sop1.html. So let's try to open sop1.html. Just right click on this and try to see the inspect element. Okay, there was some error over here. Let's try to do it one more time. XML HTTP request bugcow.com or response.text. Okay. We have already one file up and running. Let's open this with the notepad. Yep, so we are trying to open gmail.com and we're trying to get the response in a text file or in the txt on the same tab. Let's try to open this. Do right click, inspect element. We can see that cross origin request blocked because the same origin policy disallows reading the remote source, which is https gmail.com. So what I basically was trying to do is try to get the remote resource of gmail.com to this specific or this parent tab. So that's how a normal SOP blocks all the, what you can say, I was just trying to fetch the data from gmail.com, which is basically blocked me because of the SOP. Now, I have seen many researchers who try to bypass SOP, same origin policy. So just if you try to Google it out like SOP bypass, you will get a tons of threads in Bugzilla or in Chromium that there are multiple ways to bypass this specific thing, SOPs. So that's again one of the component of that's something called as same origin policy. Apart from that, we have content security policy. Now, CSP is something, a standard maintained by W3C to protect multiple attacks in browsers, right? So whenever I try to release, whenever I try to, what you can say, I release my own browser. So there are checklists being maintained by W3C so that your browser should be, it has a do's and don't for a small checklist for every browser. Like your browser should be not vulnerable to UXSS. Your browser should not be vulnerable to SOP or use inline style volatilization. Now, CSP can not be always a security bug, or it can be always a, you can report an issue by saying that the browsers is not getting passed by different do's of which is being maintained by W3C. For example, there's a small demo link over here which checks for the content security policy. If you see list test, so there are multiple tests. You can run all this test in your browser to see whether that browser is being loading it properly. For example, load style sheet from default SRC set. If you try to run this and if you get green background over there, it means that the browser is being pretty good. You can see that? Yep. So now it doesn't mean that load style sheet from the default SRC none is a security issue. It might be a normal, if it doesn't works properly, it might be a normal issue as well. So when I try to run this specific demo link in Chrome, there were multiple, what you can say, multiple things which was not getting passed as per the W3 standard. But the things which was not getting passed was not an actual security issue. So I have just reported a small bug in Chromium, which is publicly available. And they will try to patch each and everything. So just if you want to see, just run all the tests over here. And once done, oops, looks like my internet connection is a bit unstable. Okay, so once you try to run that, you will figure it out like how many things are there and is your browser is properly being maintained by as per the W3C standard. Apart from that, we have remote code executions in the picture. RCs plays a very important role and it's one of the P1 bug for browser-based bug bounties. So let's have a quick look on this. I'll be taking Mozilla for doing RC. So now we have Mozilla provides a component which is known as NSI local file. Now this component can be referred by using a string which is known as @mozilla.org file local1, which is known as contract ID. Now using this contract ID and JavaScript, we can call or refer any other components from your system or outside the system as well. For example, let's take this specific instance. Okay, let's try to define a variable b, and let's create an instant components dot interfaces dot okay, you can see over here components dot interfaces, NSI local file where you can define the path of b dot init with path. I'm trying to call C Windows system 32 cmd.exe, and let's try to launch b dot launch. Okay, and if evilness is working correctly, this should execute cmd.exe in the console log. So just do a control tab, and you can do shift control K to open your console and try to paste it over here and hit enter. Oops, it says that components are not defined. My bad. Looks like the components spell has been misspelled over here. Okay. Let's do it one more time. Whoa, saw that? So it basically executes cmd.exe. Now, executing such arbitrary code into console log may lead to remote code executions in multiple browsers, right? So in the similar fashion, we can call cal.exe, and we can call PowerShell.exe and etc. So that's how it's a very sweet example for remote code executions in Mozilla Firefox. Now there must be a different components or different instance for different browsers to run this specific thing. Now the main core component where the all browsers run is just because of JavaScript. So this is one of the necessity to be done in the browsers. Apart from that, we have something remote code execution, which was identified by Magic Month 1000. That's pretty good, like just a normal href tag, calculator with a colon, and just specify whatever you like to specify over here. Now hitting this and running this specific HTML crafted page, and once you click on that, you'll be able to execute cal.exe. In the similar fashion, you replace this with cmd.exe or PowerShell.exe, it will be able to run PowerShell or cmd.exe. So calling your system-based file from a browser, it's nothing just a remote code execution. Now this all are P1 bugs when you do go for bug bounties in browsers, executing the remote code, then bypassing the SOP, figuring it out, UXSS, and etc. This all comes under P1 priority-based bug. So this was one of the small example for remote code executions. Apart from that, we have address bar spoofing attacks. Now we are talking about spoofing attacks. We have address bar spoofing, we have navigation, we have content spoofing, and etc. So I've got few of the references, few of the videos. Let's have a look on this one. So this was one of the address bar spoofing in Chrome. So this is my parent tab, which is hackies.in/spoof.html. And once you try to click go, it executes a child tab over here. And the child tab says that the URL is pretty good, https facebook.com, but you can see the content, the web page is not a facebook.com. So I have written down a small set of code. You can check that on my blog as well. Now, this is a very small idea that how address bar spoofing basically works. Like there are multiple stuffs over here. You can mimic your address bar like it's a proper generic facebook.com, but you can change the data over here by saying that this is not a facebook.com. So that was one of the example for spoofing attack. So you can visit the blog to check out all the codes, and there are multiple spoofing attacks as well. I figured out in Mozilla and etc. If you talk about content spoofing, so that's pretty good. Oops.
Hey, Dhiraj, we're almost out of time, so let me know how close you are to being done.
Okay, I'll try to complete that.
No problem, no problem.
Sure. So we'll try to quickly run through the slides. Like there's something called as internal web pages of the browsers. Like for example, about : error $D equals. So this is one of the internal pages for Mozilla. So right, if you try to do B equals, hey, welcome to BB. Oops, look like there's some So in the similar fashion, if you see over here about :net error, where D is equals to hi, welcome to bug crowd level up. So it basically spoof the content of your browsers over here. So like I figured out running multiple JavaScripts over here as well, but I was pretty not good for running the JavaScript in this case. Okay. Apart from that, we have one more spoofing attack. Let's copy down a small HTML code, paste it, and now this spoofing attack works on event.clipboard function. Hey, welcome to background, and let's name it as copy.html or somewhat like that. Okay, so let's try to execute this. Copy.html. It says that, hey, welcome to LevelUp. Now, if someone try to copy this data, and if they try to paste it somewhere, it says that, hey, welcome to BB. So that's how you try to spoof basically the content. So in this case, I have used event.data handler function, one of the functions used being in the JavaScript. So that's one of the part. You can just copy or spoof the content, whatever you are trying to do in this case. So apart from that, we are running out of time this time, running to the slides as well. So there's one more thing that's pretty interesting. I love this. So it was done by Sebastian, Jabs, and me. What we figured out, like, if you log into any Mozilla, like if the Mozilla has multiple versions, right? So if you try to log into any web panel or website like facebook.com or gmail.com, where once we log in, we perform our dynamic activity and we log out, right? So the application might be secure, but browser at a certain level, it might be vulnerable. So what we figured out, like once you do log out, just go to view source and check this out. The view source will have all your content, all your sent mail, your draft mail, your inbox, and everything, which will be in your view source. So there's a small link over here. You can just check it out over there. So Firefox caching may hide out your privacy. If you're trying to log into your any banking sites and etc., you have put down your CVV numbers or etc. You think if you are logged out, you're pretty well secured. But if you are using Firefox, just do a Control U, go to the source code, or just do Control F and search for your CVV. But obviously, you are getting a CV. You will get a CV ID, or if whatever dynamic activity you have performed. Now, this was not. It cannot be remotely exploited. So that's why Mozilla marked it as an insecurity bug, and it became publicly. But this is one of the pretty good achievement what we guys did, Sebastian and Jabs. That's pretty interesting. Like just view source was leaking tons of data, whatever view views. Great. Apart from that, let's talk about bug bounty for browsers. Like we have browsers like Chrome, Firefox, Internet Explorer, Apple Safari, and Opera, which provides bounties, and there are much as well. So why bug bounties in browsers? We get tons of dollars as well over there, and we are targeting products, so that's why we get CV IDs for that. So you can request to vendors, like we can request to Chrome or Firefox by saying that there wasn't a specific issue. If the issue is being passed, please reward me with a CV ID as well, or please request you to give me a CV. So CV is one of the key, key points for bug bounty in browsers. Apart from that, we have +1 for reporting format. Again, it's applied for your normal, what we do in our day-to-day bug bounty, and similar fashion, it applies for your browser-based bug bounties as well. If you are trying out bounties for Mozilla, so we have multiple things like Firefox Beta, Developer, ESR, Nightly. Then we have Firefox for Android. We have Firefox for iOS. Now, for Firefox Focus will be there for Android as well. Oh yeah, both are there. Then we have Firefox for iOS. So you can just figure it out, like there are multiple products over here. If you are trying to craft some malicious packet for Firefox Nightly, if it doesn't work there, so don't be upset. We have multiple products to check over here, and you can use Bugzilla for reporting this specific link. So if you figure out any security issues in Firefox, just go to bugzilla.mozilla.org, and you can just open a ticket and mark it as a security bug, and you can push the thread over there so that the security people from the Mozilla can have a look on that. In the similar fashion, we have Chrome, Chrome Beta, Developer, Chromium, Chrome for Android, Chrome for iOS, and etc. We have bugs.chromium.org. It's one of the applications. You can go, you can open a thread, mark it as a security bug, and you can push it if you figure out something over there. The best and the challenging part of Chrome for now, I figured out the XSS auditor for Chrome. It's a pretty good example. Like you can do it every morning with your bread and butter. For example, testfire.net. This is Chrome, right? So D007, let's try to execute any XSS over here. Okay, it says that error blocked by XSS auditor. So what Chrome says that if you're able to bypass this XSS auditor, they will provide you bounty for this as well. So if you're a great XSS, or if you have a tons of knowledge about XSS, you can just go to testfire.net. This is one of the testing website, and you can test for multiple XSS test cases. And if you're able to bypass the XSS auditor for Chrome, just report them to bugs.chromium.org. So that's one of the challenging and very interesting part for application security testers, as well as who are testing for browsers-based bug bounties. If you're looking for issues in Safari, we have Safari for iOS, Safari for Windows as well, but I believe now it is being outdated, or it is being not in scope, like Safari for Windows is not been in scope for browser-based bounties. For that, you can report it to product-security@apple.com. And there are pretty much other different browsers. Like for Bitdefender, we have a browser known as SafePay. They give you bounty as well. There's something called as Intel TrueKey. Now, Intel TrueKey is an application which collects all your password and creates a master password, somewhat like that. But what you can do, Intel TrueKey also has a what you can say, a browser inbuilt in the application. So you can test that as well. There's a Twitter WebView. Then there's the Yandex browser. We have Kaspersky browser for Windows and Android as well. And then there is a stock browser, which is an inbuilt browser for Android cell phones. So apart from Mozilla, Firefox, or rest all the famous other browsers, we have this much browser, and there are multiple like Brave, which I have not mentioned in this over here. And there are pretty much many different browsers in Android market as well. So if you try to figure out any issues, any one of the browser, you can just go and perform the test cases on multiple browsers as well. So yep, that's all from my side. Thank you very much. Hope you guys enjoyed it. And yep, if any Q&A, just let me know.